We can also gather some extra data using secondary sources such as maps. So here I've got a map of the River Charmdale, and the first thing I've done is I've just plotted on all the different river sites that we studied going along the way. So this helps us to explain our results. Perhaps we can look for some anomalies, or perhaps there's a tributary coming in which is causing an extra big flow of water. And it's also really good for the reader to be able to see exactly where we've gone and to be able to understand what we saw when we were out there. So the other thing that we can do with these maps is we can work out the drainage basin area. For this, I have an overlay which has split the kilometre square grids from the OS map into a further 16 boxes here. So what I'm going to do first is I'm going to mark on all the highest points around my river course. So you can do this at looking at the elevation numbers and also looking out for little cairn signs. Next, I'm going to join them together just like a dot to dot around my river. So going between the highest points and ending down at the mouth, down here. The next thing I'm going to do is I'm going to count up all these little boxes inside my shape. Once you've counted those all up, you're going to divide it by 16 because this will give us our drainage basin size in kilometres squared. With all our data collected, it's time to start presenting our graphs and starting to interpret our results. It can be really useful to first create a massive table with all your data in so it's all together in one place. And remember to check the units as you're putting it in that they're all the same. So the first graph we're going to look at doing is for cross-sectional area. So cross-sectional area is just width times depth. So we're going to plot those onto a graph. I've put my width across the top and my depth going down my y-axis. Again, remember to check that both your units are in the same, so mine are both in centimetres. Now you can think about this graph just as width as being your surface water going across the top, and then going down we're just going to be plotting on the shape of the basin of the river going across the bottom. So once we've got those on and a nice scale going across each way, you can start plotting on your results. So I've plotted on all my results here, and remember you need to make sure you're plotting them on in the interval that you measured your width in. Once I've plotted them all up, I joined them with a line and I counted all the squares that are inside my graph. So I counted that there were 64 squares. So once you've counted, make sure you write that number down somewhere. I then need to work out how many squares there are inside 1 metre squared. So for me, my graph goes down to 50 centimetres and I'll go across to 200 centimetres because that would equal 1 metre squared. And I then count up all these squares inside my 1 metre squared, which is 40 little squares. So next I need to do 64 divided by 40, and that will give my cross-sectional area, which is 1.6 metres squared. Scatter graphs show correlations between two sets of data and whether they're positive or negative. On them, we can also identify any anomalies. So now I've got all my points plotted, I can add a line of best fit. Your line of best fit should go roughly through half of all your data points. It'll have the same amount either side. So I'll pop mine on here like so. So I can see that I've got a negative trend because it's going downwards. However, I've also got an anomaly here which doesn't quite fit in with the rest of my data. So I'm going to circle him, and later on in my conclusion I try and explain why I've got an anomaly there. Perhaps it's from the flooding last year which brought down some big bits of debris and deposited them. On here you can also see that I've labelled both my axes, I've got some units on them, and I've also got my title.